Okay, so now let's talk about what you gotta do whenever you do not have common denominators, because everything we talked about in the last video, they all had nice common denominators from the beginning, and we know that doesn't always happen in reality. So just basic fractions, not with variables in there yet. If we have, say, 1/2 plus 2/5, obviously one of those fractions has a denominator of 2, and one of them has a denominator of 5, so those are not common denominators. We can't add or subtract fractions unless we have common denominators. So the first thing we have to do is figure out how to get those two fractions to have the same denominator. Hopefully you guys remember, but the way we're going to have to do that is we're going to have to take each fraction and multiply it by some number on top and bottom so that we can change both of them. Well, in that case, we need to find a least common we need to find a least common denominator, least common multiple, whatever you want to call it. We need to figure out something that 2 and 5 can both multiply up to. Well, easy answer would be 10, because if 2 and 5 are my denominators, just take them times each other, and you should get a common denominator. In this case, 2 times 5 gives us 10. So now I know my goal is to get each of these fractions to have a denominator of 10. If we look at the first one, 1/2. Well, the way I get from 2 to 10 is to multiply by 5. But obviously I can't just randomly multiply by 5 in the denominator and say that that's okay. If I'm going to multiply by 5 in the denominator, I also have to multiply the numerator by 5. Because if you think about the fraction 5/5, that's really just 1. And if you multiply something by 1, you're not actually changing it, so that's what makes this okay. So if I take 1 times 5, I get 5. If I take 2 times 5, I get 10. So 5/10 is the same thing as 1/2. If I look at my next fraction, 2/5, in order to get my denominator from 5 to 10, the way I would need to do that is I would need to multiply by 2. But again, I can't just randomly multiply by 2 on the bottom. If I'm going to do that, I also have to multiply by 2 on top. 2 times 2 would give me 4. 5 times 2 would give me 10. Okay, great. So now I have been able to successfully get my denominators to both be the same thing. I now have a common denominator of 10. Now that I have a common denominator, I can just go ahead and add them the same way we did in the last video. So I don't change the denominator, that's just going to be 10. I only combine my numerators, so 5 plus 4 is 9. And that would be my answer for that problem. Now let's talk about doing that with variables, what we're actually doing for this lesson, because you guys kind of learned fractions before this year. So let's just say I ask you to do 1/x plus 2 plus 2/x plus 5. Just stick x's as both the ones that we just did. Okay. So, looking at my denominators, just like before, those are definitely not common denominators. One of them is x plus 2, one of them is x plus 5. The key here is remembering what I've already said multiple times in the last few days. X plus 2 is a quantity, x plus 5 is a quantity. So no, this is not a scenario where they both have x in common, it's just the 2 and the 5 that's a problem. The quantity of x plus 2 is different than the quantity of x plus 5. Their denominators do not have anything in common. Okay? So just like in the previous example, when we said, okay, 2 and 5 have nothing in common, so easiest way to find a common denominator is to just take my two denominators times each other, 2 times 5. Because these denominators also have nothing in common, the easiest common denominator that I can try and get is going to just make both fractions have x plus 2 and x plus 5 together. That would be my least common denominator. Okay? You do not ever need to FOIL out your denominators, meaning how I've written it over here in the top right of the screen, that's exactly how you can leave your denominators. I don't need you to FOIL them out, it's not necessary. If that is our goal, if the top right there, the x plus 2 and x plus 5 is our goal, we need to figure out what we need to multiply each fraction by to get that. So, if we look at my first fraction here, we've got 1/x plus 2. Well, that means I have the quantity of x plus 2 already. That's good. I'm halfway to my common denominator. What I'm missing is the x plus 5. Well, if I'm missing the x plus 5, then that means I need to multiply it in there myself. But just like before, I can't randomly multiply an x plus 5 in there. I'm going to have to do that on top and bottom. Okay, so 1 times x plus 5, well, 1 times x is x, 1 times 5 is 5, so I have x plus 5 on top, and on bottom now I have both x plus 2 and x plus 5. Again, we don't need to FOIL those out. The way I've written it is just fine. Looking at my second fraction, we have 2 over x plus 5. So, we've got the x plus 5 quantity that we want. What we're missing is the x plus 2. So, I need to multiply by the quantity x plus 2 on top and bottom. Now, in the earlier fraction, if you didn't realize we should be distributing, you would have got away with it anyways because 1 times anything is itself. On this fraction, it's imperative that you understand x plus 2 is a quantity, which means if I'm taking this 2 times a quantity, the only way to do that is to distribute this 2 to everything inside the parentheses. So 2 times x would give me 2x, 2 times 2 would give me 4, and then my denominator is now x plus 5 and x plus 2. Again, you don't have to FOIL those out. If you look at what we have here at the bottom, recognize this is a common denominator. Okay, think about what's happening between those two quantities. They're multiplying in that denominator, right? We know multiplication is commutative. 2 times 3 is the same as 3 times 2. So if I have an x plus 2 and an x plus 5 that are multiplying together, it doesn't matter which one I write first. Those two fractions do still have a common denominator. So, knowing that they have a common denominator, that means I'm able to actually solve out this problem. So it's up to you which one you want to write for your denominator. I'm going to write it as x plus 2 and then x plus 5, just because. But if you write x plus 5 and x plus 2, still fine. Doesn't matter. Same thing. On top, we actually are going, our numerator, we actually are going to combine these terms. So, I have an x and a 2x. X plus 2x would be 3x. I have a 5 and I have a 4. 5 plus 4 would be 9. You could say that's a final answer. The better final answer would be to notice that with what we happen to get on top, that is actually still factorable. So it would be best to pull that GCF out and write this for a final answer, even though it doesn't really do anything for you, because that 3 can't cancel out with anything. It still is better to keep things as factored as possible. Alright. Last type of example I want to talk about. Okay, still not a common denominator. Let's say we have 2 over x squared plus 5x plus 6. We'll throw a subtraction in here for the heck of it. Bear with me as I think of another problem over here. We'll do this as, let's just do 3. What do we want for denominator? Let's do x squared plus 7x plus 12. Yeah, that ought to work. Alright, so we've got 2 over x squared plus 5x plus 6 minus 3 over x squared plus 7x plus 12. Now, it doesn't take a genius to see that those denominators are not common. However, I don't know right now if they share anything at all or whether they are completely different. Just like the last section, if you have the ability to factor, you should factor. So, both of these are X method scenarios, meaning we are looking for two numbers that multiply to 6 and add to 5 on my first denominator. And in my second denominator, we're looking for two numbers that multiply to 12 and add to 7. Might not be a terrible idea to pause the video here for a few seconds here, just to figure out these X methods yourself, just to make sure you still got this kind of stuff. Two numbers that multiply to 6 and add to 5 would be 2 and 3. 2 times 3 is 6, 2 plus 3 is 5. So that means I could rewrite my first fraction as 2 over x plus 2 and x plus 3. My second fraction, two numbers that multiply to 12 and add to 7, would be 3 and 4. 3 times 4 is 12, 3 plus 4 is 7. While we're rewriting that fraction, I'm also going to take care of that minus. I'm going to make it a plus negative 3. And then I'll also change the denominator to x plus 3 and x plus 4. If you watched the last video, you already hopefully understand why I'm changing that to a plus and a negative 3 instead of leaving it as a minus. Alright, so looking at these two fractions, we can see they are still different. However, by factoring, we can see there is some things that they have in common. In this case, namely, x plus 3. Both fractions have x plus 3 in their denominator. So because of that, I do not need to worry about multiplying anything by x plus 3. They both have x plus 3, so they're fine where they're at. What I do have a problem with is that I see the first fraction has an x plus 2 right here, and my second fraction, instead of x plus 2, has an x plus 4. Those are different, so that's my problem. If I want to find a common denominator so I can combine these, I know x plus 3 is part of that common denominator, but they already have that in common, that's fine. What I need is for both fractions to have x plus 2 and x plus 4. Those are the two things that I have to care about in this case. Meaning, looking at my first fraction, I have to take 2 over x plus 2, x plus 3, and I need to multiply by x plus 4 on top and bottom, because that's what I'm missing in my first fraction. So, 2 times x is 2x, 2 times 4 is 8. My denominator, since I don't have to multiply these out, please don't make yourself go to all the extra effort of multiplying these out when you don't have to. I just write out all three of these quantities. Doesn't matter the order, that's just the three quantities that I'm trying to get for a common denominator. For my second fraction, I've got negative 3 over x plus 3 and x plus 4. So I have two of the three that I need, but the x plus 2 that my first fraction has, I do not have in this one yet. So I need to multiply that x plus 2 in here so I can get both these fractions to have a common denominator. Again, have to do that on both top and bottom, which means this negative 3 is going to need to distribute. Again, hopefully you're realizing why I made such a big deal last video about the negative, because looking at all the work you're doing here, it would really stink if you got this problem wrong simply because you messed up with the negative. Make sure you're careful whenever you're subtracting. Negative 3 times x would be a negative 3x. Negative 3 times 2 would be a negative 6. And then for my denominator, I've got x plus 3, I've got x plus 4, and now we have x plus 2 as well. Again, while those factors are not in the same order, these denominators are definitely still common denominators. Since they're common, that allows me to go ahead and combine these for a final answer. 2x minus 3x would be a negative x. 8 minus 6, 8 plus negative 6, would be 2. And then pick what order you want to write your factors in for your denominator. doesn't matter though, as long as you have these four quantities, this would be your final answer. Again, do remember negative x plus 2 is not the same as positive x plus 2, so you cannot do any canceling here. No, you cannot just pull the negative out for GCF factoring, because remember, if you pull the negative out, that would give you an x minus 2, which still would not factor out. So there is no simplifying to be done with this. That is your final answer.